You know, when you're managing a massive industrial project, we all tend to focus on the big-ticket items, the giant machinery, the complex control systems. But what if I told you that the long-term success or even the catastrophic failure of that entire project could come down to something as simple as a cable tray, especially when it has to survive in a seriously tough environment?
Okay, let's just jump right in with the proof. This isn't some lab test. This is the real deal from a wastewater treatment plant back in 2023. Take a look at this. After just a year and a half, the galvanized steel trays were getting seriously eaten away. We're talking pitting up to 0.5 millimeter deep. But now look at the aluminum. Zero. No measurable section loss at all. This right here, this is the result we're all aiming for. And getting it starts with a smart spec sheet.
So how do we get there? Well, here's our roadmap. First, we're going to look at why these two metals perform so differently. Then we'll get into the absolute must-know rules, matching the right alloy to the right job, how to avoid this crazy hidden battery effect, planning for Mother Nature's temperature swings, and picking the right protective finish. Then we'll wrap it all up.
All right, first up, a tale of two metals. Look, understanding the why behind aluminum's massive advantage isn't just nice to know, it's mission critical. This is the foundation for specifying it correctly. It's not magic, it's just really cool material science.
And here it is. This is aluminum's secret weapon. The second it hits the air, it builds its own suit of armor. This incredibly tough but super thin protective oxide layer. We're talking nanometers thick. And the best part? If it gets scratched, it instantly heals itself. It just repairs the damage on its own. This is that passive self-healing shield that stood up to that nasty environment we saw in the first slide.
So that brings us to our first big rule. You can't just write aluminum on the spec sheet and call it a day. Not all aluminum is created equal. And believe me, picking the wrong one can have some really serious structural consequences.
And you can see exactly what I mean right here. For most of your standard jobs, support spans under 3 meters, 6063-T5 is your guy. It does the job perfectly. But the second you go over 3 meters, or you're dealing with really heavy cables, you have got to step up to 6061-T6. I mean, look at that yield strength. It's nearly double the standard alloy. That's your heavy lifter. That's what stops the sagging and prevents a failure.
Now for rule number 2. And I want you to really pay attention to this one, because it's a warning. There's a silent but incredibly destructive force that can completely wreck your installation if you're not careful. It's called galvanic corrosion.
Here's the key takeaway. When you connect two different metals, say your aluminum tray and a galvanized steel fitting, and then you just add a little moisture from humidity or rain, you're not just making a connection. You are literally creating a battery, a project-destroying battery. And we're not talking about a weak one either. The electrical potential between aluminum and that zinc-coated steel can be as high as 0.7 volts. Think about that. That's more than half the voltage of a standard AA battery. It's more than enough juice to power a relentless, destructive chemical reaction. And here's exactly how that little battery causes a huge disaster. It all starts with a seemingly harmless decision, right? Let's use a cheaper steel fitting to save a few bucks. Then, moisture gets in. That 0.7 volt current starts flowing. But here's the crazy part. In this electrical circuit, the aluminum becomes the anode. It literally sacrifices itself and corrodes away to protect the steel. So that tiny saving on a fitting just guaranteed the failure of the expensive tray it's attached to.
Okay, on to rule number 3. We've covered chemistry, so now let's talk a little physics. You have to respect the powerful unseen forces of nature. I'm talking about the expansion and contraction that happens with temperature changes, especially outdoors.
Now get a load of this number. A single 60-meter run of aluminum cable tray, it can grow and shrink by 55 millimeters. That's over 2 inches, all from a pretty standard 40°C temperature swing. Can you imagine that much force pushing and pulling on your supports? If you don't plan for it, the whole thing will buckle, warp, and basically destroy itself.
And this right here is why expansion splice plates are absolutely non-negotiable. They are not some optional accessory you can just skip to save a bit of cash. On any long run, you have to install them at least every 30 meters. They're what lets the system breathe, absorbing all that movement safely. They are a fundamental structural requirement, period.
And that leads us to our final rule. We already know aluminum has its own natural defenses, right? But in really aggressive places, that base material needs some extra armor. You have to pick a finish that's specifically built for the environmental battle it's about to fight.
Luckily, we don't have to guess. the international standard IEC 6157 gives us a super clear guide. You can see it in the table. If you're indoors in a dry space like a data center, class 1 or 2, the standard mill finish is totally fine. But move to a humid industrial setting, class 3, and you need to step it up to a type 2 anodize. And for the really nasty stuff, like coastal or salty areas in class 4, nothing less than a thick 20 to 25 micron type 3 hard anodize is gonna cut it. So let's bring this all home. These aren't just 4 random rules to remember. When you put them together, they form a complete strategy, a game plan for making sure your project is safe, reliable, and built to last.
So let's just run through them one last time. It's pretty simple, really. 1. Match the alloy to the load and the span. 2. Keep it isolated from other metals to stop that destructive battery effect. 3. Always plan for thermal movement. And 4. Specify the right environmental finish for the job.
And look, if you need a financial reason to follow these rules, this quote says it all. Cutting corners on an alloy, or a fitting, or a finish. Yeah, it might save you a tiny bit of money up front, but that cost is almost always paid back, with interest, in expensive repairs, downtime, and major headaches just a few years later. So here's the final thought I want to leave you with. Whether it's corrosion, heavy loads, temperature swings, or all three, your next project is pretty much guaranteed to face at least one of these challenges. So the only real question is your spec sheet ready for it?